We're out here at Quinlan Covered Bridge on a crisp winter day, and I'm with Declan McCabe, who has just written the book called Turning Stones. I'm very excited about this book, Declan. Can you tell me a little more?
Yeah, it came from a series of essays that I wrote for Northern Woodlands and The Outside Story, and it's divided up into sections. You know, we got flowing water, standing water, things that live on the surface tension, and things that emerge, and then environmental issues and things that we can do to improve water quality.
Love it. I've thoroughly enjoyed reading it. I highly recommend it to anyone who's interested in natural history. And it's very relevant for us today because we're here to look at Lewis Creek. And we're going to look at the life that depends on it, from the bears and the deer to the aquatic insects. And we're going to think of it in a zoomed out way as a watershed and all the habitat that it provides and supports. And then we're going to go right in tight and look at the aquatic insects in the stream. And you chose this spot for a reason.
Absolutely, yeah. This is one of my go-to spots. I bring students here primarily because it's very, very high biological diversity. And of course, the other thing is convenience. You can simply pull over and step right into the river.
Which I know you're going to do. I'm still debating, but
well,
I'm going to watch you
we've
do it.
got the gear, and you're
We'll
welcome
see.
to do it.
We'll see what happens.
But we've had some rainfall, so the river's quite big today.
Okay, well, and we're going to walk down the creek a little bit and meet Andrea Morgante, who
Excellent.
has been working with the Lewis Creek Watershed Association to protect Lewis Creek for so many years. And,
I love Lewis Creek Association.
So she's
Good
going to
folks.
add a lot to the conversation, especially the larger context of where we are.
Excellent. All right, let's
go.
do it.
Let's go find her. So
Fantastic.
I think Andrea's going to be waiting for us a little downstream on the bank, and we'll go chat with her a bit.
As we go by, if you don't mind a little
let's
side
stop.
trip here.
No, we're here to learn.
We got one of these cool, this is one of the white oaks, and a lot of trees will lose their leaves early in the season, and those leaves are food instantly for the river insects. But something like an oak holds onto the leaves, and all of the secondary compounds that are in there protecting that leaf when it was alive are still there. But this will eventually fall in, and it'll soak like a tea bag for a long time, and those compounds will go away, and then it becomes edible. And it gets colonized by fungi and things, and it forms the base of the food web. So having those diverse trees, the early falling tender leaves and the late falling leathery leaves, works really well for feeding the ecosystem all through the whole season.
Wow, and what happens in the stream also happens in the forest, because one of my favorite Robert Frost lines is he talks about oak leaves and how late in the fall they fit the earth like a leather glove.
Oh,
isn't it true? Like
amazing.
they were one of the last ones left, really hanging on into the winter.
They're watching you to rake, and when you're finished raking, then they fall. So don't rake.
Let's go find Andrea. So Andrea's going to meet us down here along the creek. I'm excited to be able to talk to her about what she's been up to, her role. Hey, hello, Andrea. Thank you for coming out to talk to us about Lewis Creek. You know Declan McCabe.
Oh yeah, hi.
Good to see you again. How's it
All
going?
things water, huh?
Yeah. Nice sunny day.
Yeah.
Oh, yeah.
Well, we're here to start to tell the story of Lewis Creek, and particularly think about the life that depends on it and the history that it has. And I know you've been closely connected to Lewis Creek for a long time. Tell me about how you first became interested in.
Yeah, I guess Lewis Creek is kind of my second home. I live in the La Platte watershed, but I've spent a lot of time, almost 50 years, within the watershed, from Starksboro down to the mouth in Ferrisburg. I live in Heinsberg, and I think what strikes me about having experiences in kind of two places of the La Platte watershed and Lewis Creek is how different they are, and yet you can cross the watershed line dozens of times in these towns that are in the Lewis Creek watershed. There's 7 towns that drain into the watershed, and each part of the watershed is so different, and yet the water is moving through it. The water is the same, but the geology changes from the headwaters to the mouth. The people change, the soils change, the vegetation, the animals moving around. It's just an incredibly diverse landscape, and the relationship and learning about how the relationships between land and water people and animals is just a fascinating story, and I've come to love it.
Thank you. As you're talking, I remember that we stood on Carse Hill and looked across the watershed the fall before last with some field naturalist students, and one of them took a beautiful shot at sunset where you could really get a sense of the bowl that a watershed is and all the things that it contains as the water runs down from the mountains to Lake Champlain.
Yeah.
It was just such a striking image that this is home for people.
It's home. It's an 81 square mile watershed, and about a little less than 50 miles of water streams flowing into the main stem.
Cool.
And it's one of the few direct drainages into Lake Champlain. It's a very discreet watershed.
Yeah.
You can get to know the people, the animals, the plants in the watershed on a really intimate level.
Nice. Well, today we're going to focus on animals. I love the people, and I've gotten to meet a number of those over the years, but we want to think about the animals, and we had Vermont Master Naturalists put cameras out along Lewis Creek, and they caught some beautiful photos. Declan, there was one of a little herd of deer crossing the creek, and it was just magical, their tails up. And I mean,
it was just upstream from here, just above Scott Pond. We had a wildlife camera there, and that was, we had cameras, I think, in 6 or 7 spots within the watershed, but that one was the most diverse animal populations, and the shots of the deer were just great.
And bear?
And bear,
Nice close-ups, like beauty shots of bear and bobcats.
Totally, and bobcats.
You work with cameras, you get great shots sometimes.
Yeah, we don't get bears on campus though.
No.
So most of the work is on campus, but
you've done some work in South Burlington with cameras.
Yeah, we got beautiful bobcat shot there too. And coyotes, of course, and we got some blonde coyotes, so there's some interesting things happening out there.
When you start putting cameras out, you just realize how much wildlife is out there.
Oh, because they're so infinitely patient. You know, there's lots of bird watchers, but there aren't many mammal watchers.
So the cameras are patient. Like they just sit there for you and they catch what comes by.
Right.
Yeah. I mean, you have an interesting arc with this, that you started out very focused on aquatic insects.
Yeah.
And then you pivoted more toward mammals because of student interest?
Yes, and that's one of the joys of working at a small college. There's nobody saying stay in your lane. There's not a mammologist across the hallway who's doing that work. So if the students want to do it, they go to the nearest field biologist, and that will be me.
And I remember running into you one time. It was the most serendipitous thing. We were out with a Vermont Master Naturalist group, but you had a Vermont Master Naturalist team and students out putting out cameras, and we ran into you.
Yeah, that was on one of the properties that South Burlington was interested in monitoring. Yeah.
Because there is work now to try to figure out wildlife corridors.
Oh, yeah.
And how to keep the landscape intact.
Oh.
And a watershed level is a good way to start to think about that.
Right, and in fact, that was our first project as the Lewis Creek Association, because as we were forming, which was in the late 80s, early 90s, there was a big human population migration into the watershed. And one of the things that we realized was that in order to protect and appreciate the watershed, we needed to educate ourselves. And one of the ways of doing that was to bringing all these people who didn't necessarily know each other, had recently moved to the watershed, was by finding the common interest, and the common interest was in wildlife. And so we started doing transects, and with Sue Morris from Keeping Track. As she was forming Keeping Track, we made groups of going out and following prescribed tracks, and then we worked with Vermont Fish and Wildlife, really identifying all the road crossings, which is a little depressing because you find road crossings because it's where there's roadkill.
Right.
And we worked a lot with Fish and Wildlife, with Sue, on identifying wildlife corridors. And it's, this was, almost over 30 years ago. And that information now, and that was the role of Lewis Creek Association, was to share that information with planning commissions, with conservation commissions, so that we can have better town planning, and that our planning and our zoning could ignore the political boundaries that we have
Right.
and respect a watershed and
Yeah, a little
understand how
holistic.
the watershed works and the water and the importance of doing that kind of planning at a watershed scale.
That's so important. It is.
Absolutely, yeah.
Yeah.
And those corridors are vitally important.
Yeah.
There was similarly in South Burlington, there was interested in a property that the perception was there was no wildlife in it. And we went in and we documented, otters, we documented bobcats. And they were actually using the watershed, they're using the culverts that carry the rivers underneath the highway.
Yeah.
And the animals are going through those culverts as a way to avoid the highway.
And that's a point where people can actually take direct action to make those better.
Yeah.
I know in Moncton there's been a
and
real...
then that was a big role for us to learn about the importance of amphibians.
Yeah.
And then and how there's such a diverse species of amphibians and reptiles, herps.
Yeah.
And being able to actually get the first federally funded wildlife crossing in Vermont was for amphibians in Moncton. And it was a great experience working with the Moncton Conservation Commission, doing an online fundraising campaign. We got donations from all over the world because our awareness of amphibians and I think their relationship to what you're going to talk about,
Absolutely.
the insects and the macroinvertebrates.
Absolutely.
Yeah, let's circle to that. I want to say one last thing, which is I have seen videos on that crossing in the amphibian migration moment when it's raining on a cold night in April, and it's just hopping in there. There's so much wildlife.
Very, very
Absolutely,
effective.
yeah, and the bobcats are using it.
Yeah.
We kind of joked as we were doing the project, we're building a salad bar for the raccoons. Basically, it's not only the amphibians that found it, but the animals that prey on them as well. Yeah.
And I was talking to Jens Hawkins-Hilke the other day, and they're doing something really scaled up in this place called Sharkyville, I think is what they call it, over near I-89, where they're going to put in another crossing that is geared toward large mammals.
Oh,
Wow.
cool.
That's fun.
That's great.
Yeah.
That's great.
Well, let's walk on down the river. I know there's a place to go in it down here.
Yeah,
is that
absolutely,
correct?
yeah.
I'm going to follow your advice on that.
Yeah, we'll get in and out without getting too damp.
Wow, there's such amount of
There's a lot of diversity
basswood
here.
and
Yep.
willows down here.
Yep.
Here's another oak leaf.
Yeah, Declan and I were just talking about white oak, and this one's red, isn't it? And we have basswood and other things under our feet here. There's a lot of tree diversity. And why is that important for the animals that live in the watershed?
Well, certainly oaks, and especially white oaks, are prized food for deer and other kinds of terrestrial animals. And in fact, you oftentimes can't even find white oak acorns. I've searched for them in terms of trying to do some planting projects and starting from seed or from acorns, and really hard to find.
Wow.
But that's what's so amazing about the creek here, is that we find all kinds of leaves and diversity of animals and plants down here. And some of it's coming from upstream, especially after a flood.
Wow. And Declan, you've helped me understand it doesn't just stay on the bank here; it goes in the water.
Oh, absolutely.
Yeah,
You figure a dry leaf flows around the landscape, and as soon as it hits the water, it's not going any farther. The river becomes a sink, and the river is fed by the leaves. That's the whole food web. And so something like this falls in, and the fish obviously can't eat that. And if you're going fishing, you're not going to roll this up and put it on a hook, or you won't be very successful at fishing. But the insects get in there, and the insects are that branch in the food web, and the insects feed on this extensively through the whole season, and then they are something that the fish could eat. If we propagate on up through the food web, you can go all the way to, bald eagles if you'd like,
Wow.
and kingfishers and things like that. So without the leaves falling in, leaf season is really, for the river, the entire year, and it is really, really feeding the whole system and propagating through the insects all the way to the fish and the birds and to us.
Wow. So
and other times of year, the basswood is really important because of the flowers on it.
Yeah.
And basswood honey or linden honey is prized honey. So from flowering, and they smell really fragrant.
do.
They flower around the 4th of July, and oh my God,
and
they're really fragrant.
They produce these wonderful berries that are also important.
Oh wow!
Yeah, they have these little helicopters on them sometimes that help them.
Right over your head
move.
there.
Oh, yeah. This is, look how red the buds are. I love basswood buds. They're just really beautiful this time of year.
Yeah.
But I love this whole connection between like honey, or bumblebees, pollinators, leaves, and the water. And you were saying that there are insects that eat the leaves.
Yeah.
How many aquatic insects are herbivores versus carnivores?
Well, that's an interesting story. It varies by watershed and by location on the watershed. So the ones that eat the leaves, we call them shredders, rather than calling them detritivores, because they're eating a whole smorgasbord. They're eating fungus, they're eating algae, they're eating things that are attached to the leaf, they're eating the leaf itself. And so we mostly, it's a functional guild, we say they're shredders. And in a small stream where you've got an interlocking canopy, the dominant insects would be the leaf shredders. When you come to a place like this and the canopy opens up and we got sunlight coming in, then you get moving on to the grazers or scrapers that are eating more algae. And then when you get down to a big river like Mississippi, let's say, it's all filtering collectors, because there's so much, think the Mississippi mud ice cream.
Yeah.
It's all of the particles in the water that are being filtered by a whole bunch of insects that specifically filter. So it depends on where you are in the watershed. It's called the river continuum concept.
That's so interesting. I can't believe how long I've walked around this earth without thinking very much about aquatic insects. So,
well, some people obsess on insects, and some people obsess on trees, and some people obsess on the human scale of the whole landscape, and it's a good thing.
It is a good thing. So speaking of which, and I want to talk about this, I saw some beaver chew over here.
Oh, yeah. We should double back and have a look at them. Yeah.
So here's the beaver chew I was talking about. Well, and you can see, now I'm noticing several things, but this is pretty fresh. You can see how blonde it still is, but look over here these have been chewed before, and they've gone all gray and they have shoots on them. So this is a recurring thing out here, of course, with beavers. They're critical, I know, in these watersheds for slowing water down. And as I mentioned that, I noticed that there's all this flood debris in and around us from
Wednesday night. There was a flood watch all day. They were announcing it on the radio, and this is definitely in a December flood is kind of unusual. And we still see evidence of that flood from how all the grasses and the vegetation is laid down and all this debris in the stems.
Yeah.
For sure.
Yeah.
And I think, Andrea, when we talk about floodwaters, immediately my mind goes towards slowing water down and the role that beavers play in that, and other things as well. But
Absolutely.
I mean, you see the beavers are grazing on the, browsing on the willow here, but they have a lot of really important roles in a watershed in terms of slowing down the water's momentum.
Right.
Absolutely. And any beaver dam is containing water. Obviously it's containing water in the pond itself, but what people sometimes fail to recognize is they're also elevating the groundwater, because that pond is perched there and there's water pressure that has increased and it pushes water way out into the landscape. So the whole groundwater level has been elevated by the beavers. So it contains several times more water than is contained in the pond itself.
Wow.
And that's slowly released, and that's keeping your river flowing in times when there's slow water and a lack of rain, but it's also containing water and reducing the flow downstream when you might have flooding. So critically important to have in the landscape.
And this is something you've looked into, because you created a series of signs on the St. Michael campus.
There's lots of ways to be educated about this, and so we put in an interpretive trail. It was funded by the Lake Champlain Basin Program, and we have, for example, rain gardens that we've highlighted. We have gravel beds where the water runs off the gym into a gravel bed rather than to a culvert. We have areas where the water comes right off the sidewalk into the lawn instead of going to a manhole. And then we have created wetlands down in our natural area. And then UVM's Walk-in Care Centre has a retention basin from their parking lot to slow the water down and settle out the sediment that would otherwise be polluting Lake Champlain.
Beautiful.
Yeah,
So-
and Lewis Creek Association, we have been sponsoring a program called Ahead of the Storm for landowners of all sizes. And we talk about the 3 S's: slow it down, spread it out, and sink it in.
Sink it in.
That
yeah.
is the way that we are going to be controlling stormwater, and what happens naturally with the help of beavers and the importance of floodplains, and vegetation along the stream, and most importantly, allowing our rivers to regain their natural sinuosity. Most of the streams have been straightened and channelized over the past 200 years, and that is what is causing so much of the damage in our human settlement patterns, is that straightening.
Absolutely.
And so if we can allow those curves to come back in and to learn that we really can't be developing in our floodplains.
That's so important.
The straightening is so destructive. We wanted to efficiently get the water off the landscape, and a straight line seemed like the way to do it. But anybody in grade school learns that a straight line is the shortest distance between 2 points. If your river is a wavy line, it holds more water than the river that is a straight line. And instead of delivering that water straight downstream to your downstream neighbor, you are containing it longer by having a sinuous stream.
Such an excellent point. Well, and may I just say that beavers, in addition to all the services they provide, and not only when it's a pond, but later when they move on because they've eaten the food that they want to, usually hardwoods from around the pond, the bridge will, their dam will fail and it'll become a meadow. And it's a whole nother, it's a different wetland. It's certainly very important for things like moose and other species who forage down there, feed down there. So,
absolutely, yeah.
well, and as from a human perspective, people love beavers. I mean, you don't always love them when you're in conflict with them about your trees, but people always report excited to me beaver sightings that they've had, and just what a great experience it is to have the beavers are big, and have one go right under your canoe. Paddling is like amazing. And so
they're amazing animals.
They are.
And I think the important concept and idea that I just crosses so many different boundaries when we're talking about rivers is this concept of dynamic equilibrium. It's that change happening over time, the relationship between water and land, animals and plants. Dynamic equilibrium is the state that we're looking for as the river changes, and the concept of fluvial geomorphology. I think those two concepts, those two words can just say so much about the way that science is evolving. This whole science of fluvial geomorphology is relatively new, and our understanding of the importance of letting rivers speak for themselves.
And those two concepts are related, the fluvial geomorphology and the dynamic equilibrium are kind of part of this sense of a holistic approach to watersheds and how to keep them forested, as you said earlier, and intact in a way that makes them healthy and less flashy.
Absolutely. And it all feeds straight back to biodiversity. You've got the different states in the river. You've got the beaver meadow that you mentioned, the beaver pond. There are specific organisms that need each of those types of habitat. So having the beavers in the landscape contribute to the habitat diversity, which in turn feeds back to the biological diversity. So the beaver pond is full of things like dragonflies and fish that might like some slow water, as distinct from a river like this, where you're going to get your trout and other things, and the stoneflies and the things that like fast water. So you need all of those different pieces of the landscape for an intact ecosystem.
So good. Well, we're making our way to the river.
We should do it.
Let's get in the river and see what we find.
We won't get washed away.
Getting in the river in December is a novel concept.
It's all good. So that's the gear. And you can get even cheaper.
Oh, wow.
When I work with kids, I usually do the streamside zoo. When I'm back in the lab, we will sub-sample on a fancy cafeteria tray. And when we need to sieve samples, this is what we would use, and that's $50. And there's the cheap equivalent. And you can have forceps, or you can go to the pharmacy and get tweezers. Scrubbing brushes are good if you're going to sample in a lake. Microscopes are great if you're going to work in the lab, but if you're working with your average 6-year-old, magnifying glass is better. So, sample bugs. See if I don't go washed away. This is the other reason why I like this site. Somebody built me stair steps, which I really appreciate. All right, so when you sample the bugs, first thing you do is get some water so that when you come back with your net, ideally full of bugs, you've got somewhere to put them and they are not high and dry and suffocating. So it remains to be seen if I'll get any bugs today because the water is quite high so it's Friday and we had a flood on Wednesday, right? Yeah. So it remains to be seen if I can get any bugs. The bugs hunker down during floods. They go down into what's called the hyporheic zone. They go down into an oxygenated part of the groundwater. And then after the floods, they migrate back up again out of that storm cellar. Remains to be seen if they came back up yet, so we might not get any. But let's find out. This feels pretty good right here. Okay, here's what we do. Take your net, put it on the riverbed, walk upstream just a little bit, and kick over some rocks. And the idea here is that the gravel will settle fast, and the insects that you have disturbed will settle a little bit more slowly and end up in your net. So let's see how we did. Oh, we got all kinds of things. So that's exciting. Here we go. Let's see who we have. All right. So when you're doing this on a serious basis, recognize that the insects have evolved in flowing water, and therefore they're very, very well adapted for hanging on. So when we sample, one of the first things you do is it's called picking your net. So you turn the net around and see who's left in there. And right off the bat, there's one of the dipterans.
There's a fly larvae.
It's a fly larva for sure, but which dipteran it is, I'm not sure. Just pop them in the water. And over here we have a little mayfly. The mayflies typically have 3 tails at the back end, and they're better. Oh, he's gone. He's in the water. So those are the things that stick to your net, and you'd spend, a good deal of time picking and looking particularly at the seams and seeing who's hanging onto the net. There's another mayfly. Since the first one wasn't so cooperative, I'll be more careful with this one. And when we put them in the water, the mayflies often will swim a little bit better than some of the other insects. Let's see if we put him in and see if he swims. No, he's going to make a liar out of me. All right, so obviously we have some minnows in here. This thing floating on the surface is a caddisfly case. So that one is a square cross-section made out of plant material, and the caddisflies live inside that one. It's called brachycentris, and it attaches the case at the front edge like a hinge onto the surface of the rock. And that means that all 6 of its legs are available to stick out in the water column and filter particles out of the water. So that's brachycentris. I don't think anyone's home in this one. And so they are plant material held together using silk that they secrete. They have silk secreting glands in their face, essentially, and they can put that together and line the entire thing with silk. So that's a common stonefly. The thing is to give them water so that they'll stay alive and also be more inclined to stay in the container for the duration of us having them here. There's a nice crayfish. This river, sometimes I've been here where it is frozen. I wouldn't ever advise walking on a frozen river. It's very, very dangerous because you can't predict where the thinnest ice is. So don't walk on a river. But when the ice is there, the insects are actively feeding. They're still doing their thing. And most aquatic insect growth actually happens in the winter. So they're quite opposite to a lot of our insects in that they are taking advantage of that leaf supply that has just fallen in. So leaf season for them is after our leaf peepers have left. And so they're feeding and growing all winter, and then when it's summertime they can emerge as adults and they can fly around, and that's when it's warm enough for their flight muscles to actually work. If they were coming out of the river right now, it would be too cold for them to fly. And so many of the insects that you see in winter are wingless insects. There's quite a few of those, and insects that will crawl around on top of the snow rather than trying to fly when it's physically impossible.
I heard you say once, Declan, that mayflies, people think they only live for a day, but they've already lived for how many months underwater?
Yeah, the very name Ephemeroptera is ephemeral, right?
Right.
And so that's the stereotype, the mayfly only lives for a day. And that's the adult phase, and they do live for a day or 2 days or 3 days. But depending on the species, like the burrowing mayflies that come out of Lake Champlain have been there for 2 years.
Wow.
So they've had a very long, prolonged adolescence that maybe the rest of us could envy, you know, before they become adults and have responsibilities like finding mates and laying eggs.
Wow.
But some of these things never come out. Like the crayfish has no part of its life cycle that isn't in the water. So those are the non-emergent organisms. Most of the other things, the insects, have what we call an emergent life cycle, where they're feeding here for 2 years or a year, depending on the species, or even less, and they emerge as adults at that point. And that's kind of a cool way that closes the loop, because the leaves that fell in from the landscape and fed this whole ecosystem, now that ecosystem is producing something that comes out of the water and is feeding bats and feeding swallows and swifts and other insectivores in the landscape. So it closes the loop, which I think is really cool.
So I'm guessing as we comb through the collection that you have here, we'll find new stuff. But we're going to go back to the lab and spend some time really getting introduced to these organisms and more of the stories that you're telling us.
For sure,
yeah. I'm excited about that.
So it's time for the fish to go. When I collect, I try not to collect fish. I haven't got permits for collecting fish, and they're not part of the studies that I do. So I set them free and let them live another day. And they're contributing their part of the food web also. There's a big one in there somewhere. Where'd he go? I haven't found him. There he is. All right, buddy, come on. Out you go. There he goes. All right. I'll get some more water for my bugs so that they're happy as I bring them back to the lab. There we go. Oh. Welcome to my strange world.
happy to be here. Yeah. So Andrea, what a pleasure to see you, and thank you for coming out and spending some time with us on this cold morning.
Yeah.
It's been great to get your perspective on Lewis Creek. I always admire the work that you're doing out here. And
well, I just love being out here. I'm not sure I would have chosen to come out here today, and I was kind of thinking it was nice, but when I'm out here, there's just always something amazing to see, and the beauty of the ice forming on those branches when the water was high was just amazing. So it was totally worth it.
That scene really has struck me too, just the dangling ice sculptures over the water.
Yeah.
So that's one of the fun things about winter for me, are the things that are created by the winter conditions that you wouldn't see any other time of year.
Yeah.
Anyway, lovely to explore with you.
Yeah.
And I wish you could join us in the lab, but I know you have things to do.
Yeah.
So we'll catch up next time.
Cool.
All righty.
Thanks so much.
Yeah. Declan?
Hello.
Hey.
Hey.
Hey, good.
Welcome to my corner of the planet.
Thank you. We're reconvening to look at these insects we got out of Lewis Creek, huh?
Yeah, well, these are some older pickled ones. We'll look at these too.
Okay.
But let's get the Lewis Creek ones.
Excellent.
Because they're alive and happy looking, rather than looking at something that was pickled by students 20 years ago.
Okay. Well, it's good to keep your best of, right? To show people. Hey, I noticed as I was walking in this poster.
Yeah.
Is that a recent?
It's not too recent. Both of the students have graduated, but it's a good poster, so we left it on the wall.
Yeah.
So this is looking at two acid mine tributaries, Ellie Mine and Elizabeth Mine.
Okay.
And they were copper mines a long time back. And, for a certain number of decades, we had lots of copper and everyone was happy, but the streams are still actually kicking out acidity and low pH. So not good for bugs.
And are these, where are they located, generally speaking?
They are east of Montpelier.
Okay.
So
it says South Stratford and Vermont.
You could be right.
Okay.
Yeah, there you go. You figured it out. South Stratford.
Okay. So Vermont mines that you've been sampling.
Yeah, and our chemists were interested in the water chemistry, and whenever I hear that there's a water chemistry impact, I want to know what the insect impact is. Mm-hmm. And there is definitely a diversity decline caused by the acidity that's coming out.
And we're seeing that here.
You're seeing that here, exactly.
Go back to the bugs.
Yeah, back to the bugs.
Am I allowed to call them bugs?
Well, yeah.
I mean, we're at St. Michael's College, so are they officially insects here?
Well, most of them, but
some of them are just invertebrates of other kinds.
Exactly. But most of what we have in here, they are actually insects. So you can see this big stonefly that we came out.
Caught that.
And if you're going to do this with other people, what you do is you have shallow water in your basin, keep it in the refrigerator, and you're good for a few days. They'll get plenty of oxygen because the cold water holds more oxygen. And because it's shallow, there's lots of surface area, so lots of oxygen will go in. and you'll have, these are the things you learn when you're teaching. You can't always do things in the same day, so this is how you keep things going.
Perfect.
And when you're topping up the water, you just don't use tap water, because the chlorine and the chloramines will kill everything.
Okay. Wow.
Yes.
Which is why we put it in water.
Yeah, we put it in river water
Yeah.
that we took with us, and I have a bucket sitting aside to top it up
Yeah.
if we get evaporation.
Okay.
So yeah, lots of caddisflies in here too. So
Oh yeah.
somewhere in there is a crayfish. I haven't seen him recently, but if you,
This is a caddisfly.
that is definitely a caddisfly.
I like that one.
That's Brachycentris. That's the most common case-splitting caddisfly in that river.
Okay.
So yeah, and we have net-spinning caddisflies in there too, and lots of midges. Most of them you can't see because they're tiny. Oh, there's our crayfish friend.
Oh yeah.
So he's one of our non-insects,
Yeah.
and he's trying to flip his tail and get away from me. Too small to do much damage with his claws yet, but beautiful little beasties.
I'm always surprised when I have the pleasure of sampling with you how many of these there are.
Yeah.
They're not tiny, but I
Right.
rarely see them unless I'm with you.
Yeah.
Flipping
and,
rocks and catching them.
And I have to say, for me, it doesn't get old. Like when I pull these things out, I know I'm going to get them, but most of the people with me, the delight on their faces, especially kids, to see these things that they were walking by every day, and suddenly there's this revelation that there's crazy diverse life right next to the road. You saw how far in I went.
No.
And I wasn't in there for more than 3 minutes because it was cold.
Right.
And this is what I get for 3 minutes of work.
That's just awesome.
Yeah.
So we're going to look up close at some of the ones that are a little harder to see than the crayfish.
Yeah. We'll take out some of the smaller ones and we'll put them on the microscope,
Okay.
and we'll talk about them too.
Sounds perfect. And you delight in them in and of themselves, but you also are gathering data about them. and
Absolutely,
telling
yeah.
things.
Yeah, so, one of the classic things that teachers like me do is to take students to a stream that is urban, for example, and a stream that's rural, and make that comparison. And I can show you some data that Jarrett Muzzy put together. He did these beautiful pie charts looking at the diversity in Centennial Brook in Burlington. And that one drains parking lots, and it drains the airport runway, and it drains some UVM parking lots and the hotel parking lots. And so there's a lot of impervious surface, lots of erosion, and lots of sedimentation. And the sedimentation acts like a physical pollutant. We usually think of pollution in terms of chemistry, but it's literally plugging up all of the nooks and crannies where the bugs like to live. And when you fill those nooks and crannies, there's nowhere for the insects to go during a flood. So they're exposed to the full brunt of the flood water that comes down, and they wash away. So it's super low diversity there. And then I take them up to the Red Barn and Browns River, and we pull into the parking lot there at the Snowflake Bentley Museum, and we go in there, and it's so pristine and clean by comparison. And it's not even the cleanest stream you could possibly find, but it's so much cleaner than this one. And the pie chart is much more broken up by many more diverse insects, and there isn't any one that's dominating. So it's a cool place to be. And then we go in to Joe's Snack Bar on the way home.
Excellent.
So why not?
I've been there.
Yeah.
It's worth the stop.
Yeah.
So that's Centennial Brook, and is it Millbrook?
Browns River is the
Browns
one
River.
at the Red Barn.
Browns River.
Yeah, it's a tribute. Yeah.
But this sample is from Lewis Creek. Where is it on that spectrum of?
This is it's something like 78% forested in the watershed.
Yeah.
So this is a very nice stream in terms of having cold water, oxygenated water, and a lack of sediment. When you pull a rock out of Lewis Creek, there's not a lot of sediment stuck to it. One of the things you can look at when you're comparing rivers is to reach in and pick out a rock. And if it has a bathtub ring around the rock, it suggests that it is stuck in the sediment. And so there's an index called embeddedness.
Oh, okay.
How embedded are the rocks?
Wow.
And the more firmly they're embedded, and the more of them that are embedded, the worse the stream, essentially. And Lewis Creek is on the much cleaner side of things because of all that forested land that it is draining.
Right. And
So-
people have done a lot of work to keep it.
Yeah, and the Lewis
Clean
Creek
and healthy.
Association
Yeah.
has really been instrumental in highlighting the importance of the water quality, highlighting the value that brings to the community, the human community, in addition to the insect community. I mean, that's a beautiful place for people to go fish, for example. And, Vermont, thrives on its tourist economy, and that's a piece of it. Having people be able to catch those fish.
Wow.
So, yeah.
Well, and I did pick up on something you said, which is if the cracks are all filled with sediment in a flood, things are washed away. And we know we're facing more flood incidences.
Yeah.
So all the more reason
Yeah.
to work hard to protect
Absolutely, yeah.
the quality of the streams and the stream life.
For sure.
Yeah.
You know, filling those cracks would be like a concrete truck backing up to your house and putting the chute in the window. You know, your downstairs floors in your basement would no longer be habitable. And that's what we do to the insects in the streams when we have this, what's called urban stream syndrome, where we fill up all the nooks and crannies. So, but you're right, more flooding is happening now than we've had in the past. We can't turn off climate change. We can slow it down, but we can't turn it off. So we are where we are. And we have to adapt to where we are. So, yeah, can't wind back the clock.
Beautiful. So we're going to take these next door.
Yeah,
where
yeah,
we have
yeah.
some microscopes set
We've
up.
got the microscope set up and some petri dishes, and we'll haul out these beasties and have a
All
look.
right. I'm going to bring this.
Bring it along, yes. We can set up our streams, our little zoo. So, you know, once I get things back in the lab, it's time to pull out the insects that I want to look at. If we were doing a whole sample, we would be doing this in a slightly different manner. We would be breaking it down and looking at all of this material, scoop by scoop under a microscope. But in this situation, we just want to find a selection of insects. But the insects, you put them into a little small amount of water. There's a couple of advantages of that. One is that they can get lots of oxygen fairly, you know, because of the surface area. And the other is they can't easily swim away when you're looking at them under a microscope. This is kind of a fun microscope setup. It's called dark field illumination. So what we'll see through the microscope will be mostly just the insect illuminated and then a dark background. So one thing that has changed since I started doing all this, when I started in the 90s, somebody would get a cool bug in a microscope and nobody else had one. Everybody would go look down their microscope. And now instead, we put it up on the screen and everyone gets to see it at the same time.
I love it.
Yeah.
I love it. I wish I had had this experience as an undergrad. And you were noticing, like, you see so much detail. Tell me a little what you're seeing. I know what I think I'm seeing, but...
Well, this is a mayfly flapping its gills, and it generates a lot of water current. So
yeah, do you see that?
yeah, you can see that little piece of debris going around.
Yeah, that little piece that looks like straw almost gets kicked back.
Yeah,
and is circling.
Yeah.
That is so cool.
He's constantly getting freshly oxygenated water by his gills. And that's what they need to live. And so mayflies like the cleanest of water with the most oxygen.
Wow.
So we put them in a small bubble on the petri dish, small bubble of water. So they're getting lots of oxygen diffusing into that bubble, and they'll be fine for the duration of a class or whatever you're doing. And then we return them to the cold water, and they're happy.
And this insect is adorable.
Yeah.
Is this one known sort of to be the corgi of the aquatic insects, or are they all that cute?
My problem is I think they're all cute. Like you can see between a couple of its feet there's even a little midge flipping around.
The little white thing?
Yeah.
Yeah.
And midges are the most common insect in any body of water I've ever visited.
Okay.
Usually they're so small and translucent that people don't notice them. And then some of them are big. Some of them are as large as that mayfly, and they're bright red. They're called bloodworms. And if the only thing you find in a stream is bloodworms, it's a really bad sign. It means that it is super low oxygen, and the only thing that can survive there is chironomids. But we've other things in here too. So over here we have a net spinning caddisfly. And let's see if we can get him on screen. There he is.
He is.
And you can see it has very different gills. Its gills are very feathery. And what that little insect does is it makes a fine mesh net, and it uses that net to catch particles that are washing by. So in the process of filtering small particles from the water, it's cleaning the water, it's taking food that basically very little else could eat and turning it into insect biomass. So it's the food web, you know, par excellence. And for the fly fishing people, they can't fish with particles, you know?
No.
But they could certainly imitate a net spinning caddisfly and probably catch a fish.
Wow, that's amazing.
Yeah.
The other thing is, I loved in one of your essays how you referred to this time of year is kind of following the afterlife of leaves.
Yeah.
You know, they start out on the trees in the spring, they unfurl, and then everybody wants to see them in the fall when they're all brightly colored.
Yeah.
But for aquatic systems, it's really this time of year late fall, winter, through the winter,
Yeah, right into spring. That's
that they're
the real leaf season.
serving the purpose
Yeah,
that they
yeah.
have in these aquatic systems, which is feeding
Yeah, and if you think
the
about
insects.
a river system, there's so much current, so much turbulence, so much flow, and then occasional floods. Very little in terms of large plants would actually grow in a river. So most of the productivity is coming in from outside. The base of the food web falls in, and so you've got the shredders that are eating those leaves. They're shredding them up and eating them, and they're messy eaters, and they're making particles. And the particles get filtered out by these net spinning caddisflies.
So
And
cool.
yeah, and then of course you've got larger things that are predators that are eating all of these things. So it's a whole complex food web, and you need all of the parts, and the more diverse the better. So yeah, it's a cool system. Once the students get them under microscopes, then it's time to identify things. And you can go, there's a rabbit hole, you can go as far down as you want. People ask me, did you identify the species? And there are so many thousands and tens of thousands of species you could identify that usually the answer is no. And sometimes the taxonomic keys don't even exist.
Right.
So most people start off with something like this, which is from the Stroud Water Center. And I hand those out and I print them on waterproof paper, and you can identify things very quickly stream side. So you've got a caddisfly or a mayfly or a beetle or
Love
a
it.
snail,
Aw,
and you're not trying to determine what family or genus you've got. And then to get past
wow.
that,
Yeah,
this is the beast.
yes.
And so this is sort of the standard book that you would use. It's Merritt, Cummins and Berg. It's the book, and this will get you, in most cases, to genus. In some cases, a little bit farther. And then, let's say you've got caddisflies. There's, of course, a caddisfly book.
Of course.
And there's a stonefly book.
Oh,
And there's a mayfly book. And you get the idea.
I do.
So
I do.
that's a bit of that's great if you want to be an entomologist.
Right.
But most students, in my experience, only one of them so far in 23 years has become an entomologist.
Okay.
So what I do instead is we have an app, and we developed the app with Vermont App Score.
Okay.
And St. Mike's people developed the content, and a computer science class at UVM developed the app. And our content gets pulled off a wiki site onto the app like magic. I don't even need to think about it. I don't understand how it works. Don't care. But if I hit start, I can go to Lewis Creek.
Okay.
And what I have is a handheld field guide that is specific to Lewis Creek. And these are the insects that we have found over 10 years of working in Lewis Creek.
This is really astonishing.
Isn't that cool?
That is so cool. And nice photos. You can really see them.
Yeah, the photographs are all taken with this type of equipment right here. And then we put them up to a wiki site, so we've shared them all publicly. Anyone can use them for any purpose. Yeah, and you picked on a water penny, which is one of my favorites.
Oh,
Isn't that cool?
that is so cool.
Yeah. But, if you are doing this with a class of 10-year-olds, just sorting them into a simple ice cube tray and saying, okay, I've got 10 types in this river, and I've got 3 types in this river. Already you know that there's a diversity difference, even though you don't necessarily know the names of all of the things you've collected. So
That's
yeah.
I love that you're generous with how people do this and
Yeah.
use the data.
I think it's important to, there are people who need to be entomologists, and good for them. And there are people who need to be 7-year-olds who like cool bugs and streams, and they may or may not become the same person. It's hard to say. So these ones are caddisflies.
Oh, there he is.
Is
Whoa.
he sticking his head
He
out?
did, just for a second.
Yeah. So
Yeah.
that one's the one we picked off the rock at the stream is called Brachycentrus.
Okay.
And
And is that shell made of leaf?
that is entirely made of leaf. And if we
I called
zoom
it a
in,
shell, but what? It's a case.
It's a case, yeah.
A case, yeah.
And looks like I'm not going to be able to zoom in conveniently here. But it's all made out of strips of vegetation. And it builds it. You can see it's narrow at the back end from when the larva was small. And it continues to build the case through its lifetime. And so it tapers wider to the front end. This one over here is called a minnow-like mayfly. And so it's another type of mayfly. And it's called minnow-like because it swims like a minnow.
Oh, yeah, yeah.
And he's going to cooperate a little bit for us, but he's also going to hide. So they're beautiful.
Corner.
Yeah,
They are beautiful.
they're beautiful insects, and they've got you can see they've got fuzzy gills, and on top they have like a protective shield called an operculum, and that prevents the gills from getting fouled. And yeah,
Oh, yeah.
kind of fun. Like all the mayflies, it has 3 tails at the back end,
Got it.
well, with the exceptions of the ones that have 2. But yeah, that's just to confuse students, I guess. But most of them have 3 tails at the back end.
All right.
So those are the things you're looking at to identify them.
Wow, there's something big moving over here. Is
Yeah,
that
that's the
crawdad?
crayfish. Do you want to get the crayfish out?
Crayfish. I said crawdad, showing my southern roots.
Yeah, well, common names change
Yes, they
from
do.
place to place. And yeah, I grew up in the British Isles, so a lot of the names don't transfer. Like, what we call a
He's not going to climb right out
he's
of
gonna
there.
climb,
isn't he?
yeah, he's not going to stay on there for long. So
Okay. We'll see if we can see him.
we'll see
at
what you
all.
can see, and
Okay.
I'll put a light on top of him
Okay.
because
Yeah, he's ready to travel.
yeah, he's got other
Yes, he's
plans.
got legs. We'll travel.
He's got plans that don't involve you and
Yeah,
I.
he's climbing over there. Will he eat a caddisfly?
He might. He might. They're omnivores, so they'll take almost anything.
So he's really planning. He's booking.
Yeah.
Can
Yeah.
you see him at all?
A little bit.
So what were you said there's something we might see about him that's harder to see with the
Well,
naked eye. It's hard to.
If he might cooperate, but I don't want to hurt him in any way.
No,
So I think we're going to put him back.
Okay.
The local ones tend to have, they're almost like thorns at the front end. So there's a natural place to pick up a crayfish if you don't want to get bitten,
Okay.
right?
Yeah.
Behind the legs, behind the claws, you pick them up. Every 10-year-old figures it out the first time they get bitten. And forward of that, there's a little area. And our native ones tend to have thorn-like structures at the front there.
Uh-huh.
You can feel them if you put your hands just a little bit forward. You can feel these thorny areas. You most likely have a native.
Okay.
The rusty crayfish don't have those.
Oh, okay.
So it's helpful with identification.
Excellent.
There's a big stonefly in here. I'm going to
Yeah,
see
let's
if we
pull
can
him out.
see if he'll cooperate. Yep. Here
We
we
have
have him.
any empty.
We'll put him in with this crayfish. It looks dirty.
Well,
but
he's trying to.
yeah,
have
but
him
I
look
think
too,
maybe
is
he'll
he?
sit for a bit there.
Oh, there
So,
you go.
I think-
Wow.
yeah, the stoneflies I think are truly beautiful.
You really get a sense of the difference in size
Yeah,
between that thing could fill up that whole screen, couldn't he?
yeah, yeah.
Well, I have a couple of other questions for you.
Sure.
I did bring your book, which I will gently pull from behind the.
Yeah,
One of the beauties of this book are the illustrations.
yeah. Adelaide Murphy Tyrol is wonderful.
And this you told me, Declan, was one of your favorite of the illustrations.
Yeah, it's a fun story. The duckweed disappears every fall and reappears every spring. I was like, I was wondering how Adelaide is going to illustrate this. And I had mentioned frogs in the essay as well.
And there it comes.
And here it comes.
Carrying
Yeah,
the duckweed
yeah,
up on its
yeah.
back, huh?
So I was thrilled when this one came out. I think I saw it in the Free Press or somewhere like that. And I
Yeah.
was like, oh, look at that.
That's so
illustration.
fun that
Yeah.
you don't know what they're going to be until you open.
I don't know. It's like
Yeah.
a Christmas present.
So you've always told readers of your book that you can start anywhere.
Yeah.
And one time I just flipped it open and it was the case of the confused kingfisher.
I had an idle moment one evening and I was scrolling through Facebook and I picked up this picture on the Vermont bird page and it was taken by Rich Kelly. And it was an eastern lamp mussel clamped firmly onto the bill of a kingfisher. And that's all I needed. I was like, I know what happened.
Wow. And he freed it.
Yeah, he
went
did.
over and freed
He
it
had
and
his
the
pocket
bird
knife and
flew
he
off.
wedged open.
Okay, I just want to
and
make sure people understand no one was harmed.
No one was harmed during the making of this story.
Okay.
And both parties were liberated. So the kingfisher
And the mussel
and
went
the
back
lamp
to what
mussel.
they- okay.
Yeah. And so it's all conjecture, but it makes sense biologically. When an eastern lamp mussel needs to disperse its offspring, it opens up the valves of its shell and it manufactures from its own tissues a little fake fish. And it waves the fish in the water. And the idea is that a yellow perch ideally would strike at this fake fish to eat it. And the mussel will then liberate all of its offspring. They attach onto the gills of the perch swims away, and at some point during their development they drop off in a new location. And that's how mussels disperse. And I think if the fish is good enough to fake a perch, it's good enough to fake out a kingfisher. And so the way I end the story is that there's only one way to know for sure, and I need to interview the kingfisher. I want to ask every teenager's least favorite question, which is, what were you thinking?
Yes, what were you thinking? Well, thank you, first of all,
Yeah,
for
you're welcome.
going into the cold Lewis Creek and fishing out incredible macroinvertebrates for us to look at.
Absolutely.
And it was cold because it's coming up on the holiday season.
Wow.
heard you like chocolate.
Oh my God, you
So
you know the way to my
I
heart.
brought you some.
That is super, super
And I
nice.
know you're meeting your family later, so you
Yes.
have a limited amount of time to eat all your favorites.
They might not all make it home.
Okay, perfect.
Well, thank you. I
Perfect. It's been
really
so fun
appreciate the opportunity always to talk about bugs.
spending time with you.
Yes.
And thank you for joining us on another Vermont Master Naturalist hike, plunge in the river, time in the lab, day to day. And join us next time. We'll have another adventure.